All right, so roots, radicals. I think most of this is review, but there's a few finer points at the end that you may not have thought about before or considered before. So we'll definitely slow down when we get there. But I think we know the first question here. What's the square root of 25? 5. That's great. Because how would you explain that to your? That's right. You would just say, well, 5 times 5 is 25, or 5 squared is 25. And so if you square root means what would you square to get to 25? Well, you'd square 5 to get to 25. But why is square root of 25 not equal to negative 5, even though if we, by that logic, negative 5 times negative 5 is 25? So, do you know why we don't say the square root of 25 is also negative 5? It's just not how we do it. There's a reason. But if you multiply the two negatives, you get a positive. So, it works. And the reason you're kind of struggling to answer is because basically we just decided long ago to only give the positive answer. Yeah. Who? The math council long ago. I wasn't invited, but they decided that the only one we would take is the positive one. Now that's not still much of an answer, but we don't do plus or minus. Here's a better explanation. You know what the graph of the square root looks like, I think. But if we also took the negative, like if the square root of 25 was also negative 5, it'd be a perfect sideways parabola. You're right. If square root of 25 equals negative 5, we'd have that. But what's wrong with that? What's wrong with that graph now? It's not a function. So here's why. It's answered in the next line. The square root is a symbol that we want to represent a function, so it can only have one output. Now, I suppose the math teachers long ago could have decided to pick the negative output. That would have been weird, but they could have picked that one. As long as you only have one output, you got a function. So that's why we only pick or only go with the positive one. Now, we do have to be careful. So, side note, to add confusion to things, what if x squared equals 9? What's the answer to that? Well, that one's plus or minus 3. Because I could square either one of those and get to 9. As opposed to the square root of 9 is just 3. So be careful about, if the square root's already sitting there, you only take the positive one. If you put the square roots on, if you're solving an equation, well, there's two answers to that equation, so you have to include both. So this continues to mess with people, well, at least through calculus, right? That's the highest math class we offer here, and it's still an issue for for them. So be careful. If the square root's already there, it's only the positive, only the principal is the fancy way to say that, the principal root, the main root. Again, unless it's an equation, then you could have more than one answer to an equation, but you can only have one answer to a function. Maybe that's a better way to say it. Equation versus function. Functions have one answer. Equations can have more than one answer. All right, how about the cube root of 8? What's that equal to? 2. And because, what would you use? 2 times 2 times 2, which is 2 cubed, is 8. Kind of thinking backwards. What about the fourth root of 81?
3.
Because, same reason, 3 times 3 times 3 times 3 is 3 to the fourth is 81. So the fourth root of 81 is 3. What about the cube root of negative 8? Negative 2, same reason. Negative 2 times negative 2 times negative 2 is negative 8. What about the fourth root of negative 81? Well, it's, let's say not real for now. 3i is a decent enough guess. But 3 times 3 times 3 times 3, that's right, that's 81. What's I to the fourth? Do you remember?
Well, isn't I squared negative 1, so that'd be 2 negative 1, so that's just a positive 1.
Yes, I squared is negative 1.
What? It's I1.
Yeah, but if you don't remember, you can break it down like Cooper did and say it's I squared times I squared, which is negative 1 times negative 1, which now we're back to positive 1, which means 3i is not the answer. When we get to pre-cal, we can talk about different ways to represent that. Right now, we're just going to say that that's not real. So, therefore, what we're mainly focused on here is the I don't like how this is worded, but the even root will be greater than 0. An even root, the answer will be greater than 0. As long as a is positive. Or if a is greater than 0, then the answer will be greater than 0. But if you take the even root of a negative number, it's not defined for real numbers. It's not always I, though. Again, that's a little bit beyond what we want to worry about. So even root of a negative number, for now, we're sort of back to just saying that's not real. Right? Like the first thing you learned long ago was like the square root of negative 9. You would just say, oh, we can't do that. Not real. And then we learned about imaginaries, like, oh, that's 3i. And now we're sort of back to saying, well, sometimes it's not as easy as that, so let's just go back to not real. Again, to get to pre-cal, we'll figure out how to answer that question. Oh, I didn't tell you to grab a calculator, but you can just watch on mine. Let's see. What do you think the square root of x squared looks like? Square root of x squared. So what you're thinking? Just a. Huh? Yeah. Oh, wait. What's going on there? You're right. That's the absolute value of x. Did you disagree? Let me see if I can convince you. So off to the side here. Let's say f of x is the square root.
What was it? Because x is positive and it's negative, and then the square root keeps it positive.
That's exactly right. If I plugged in negative 3, when I square negative 3, I get positive. And then when I square root,
It just goes back to 3.
it goes back to 3. It doesn't go back to negative 3 because the square root we decided was always going to be a positive answer. So if I put in a negative input, the squaring makes it positive. The square rooting doesn't change that. And so if I put in a negative, I get back a positive. Well, that sounds like absolute value. What about the cube root of x cubed?
I think it'll also be. No, it wouldn't.
This is like too hard. Can't think. Okay, well, think what happens if you put in a negative. It's going to stay negative. What about the cube root of a negative? It would be negative. So if I put in a negative, I'm going to get out a negative. If I put in a positive, definitely getting out a positive.
So is that just like a line? Sort of line?
So I think this one's going to be some sort of line. Again, the key on these is thinking about what happens when you plug in a negative. How about the fourth root of x to the fourth?
Should be absolute value of x.
Again, think about if you plug in a negative, what happens? Turns positive, and then you fourth root a positive answer. You get a positive number, so I think that's going to again be absolute value of x. I suppose we could check it just to make sure. Let's see. The fourth root of x to the fourth. Make sure we're not looking at anybody else. So our prediction is absolute value, and you're right. What about, we can put the calculator away, what about the fifth root of x to the fifth?
Be a straight line.
Just x. And the sixth root of x to the sixth? Absolute value of x. Let's try to generalize this here. So the nth root of x to the n, well, there's two answers, so we better be careful here.
If it's odd, it's going to be absolute value. If it's even, it's going to be absolute value. If it's odd, it's going to be x. It's a straight line.
Let's see if I can write what Cooper said. If n is odd, I wrote them opposite of how you said it. If n is odd, which one is it?
It's just going to be a straight line. X.
And if n is even,
It's going to be an absolute value.
because of the negative stuff. An even power wipes out the negative, and in the square root can't recover the negative. The negative's gone, lost. What about the square root of x to the sixth? Okay, so x to the third, but what happens if I plug in a negative number? It's gonna, x to the sixth will make it positive. What will the square root do to it? Yeah, keep it positive. So what do we think the square root of x to the sixth looks like?
Maybe absolute value. Fancy squiggles or something.
Okay, so absolute value, I like that because we're always going to go to positive answer. But the absolute value of what? See if we can figure out what this looks like. Oh, that's tricky looking.
Looks like
Because it looks like a parabola, but it's not a parabola.
maybe it's absolute value of x squared.
I think, well, you were right the first time when you said, you could do it like this, x 6 over 2. It's x cubed, but because of the even roots always return positive answers. Yeah, that's tricky to look on the calculator. Let's see if I can convince ourselves that it's not the same as x squared. X squared is the thicker line there. So x cubed is steeper. What about the square root of x to the fourth?
It'd just be absolute value of x squared.
Good. Absolute value of x squared. It's an even root, so you know it's going to be positive. Absolute value of x squared. What about the fourth root of x to the 12th?
Absolute value of x cubed.
And the cube root of x to the 15th? X to the 5th, but not absolute values. Right, because if I plug in a negative, 15 of them will still be negative, and a cube root will still be negative. So that odd power and odd roots preserve negatives. Odd roots and powers preserve negatives. Maybe that's the best way to phrase that. All right, some practice work here. Sixth root of 64. Let's do them one piece at a time here. Sixth root of 64.
Probably 2.
It's definitely not 4. 4 times 4 is 16. Times 4 is 64, and that was only 3 of them, so that's out. 2. So that's 2. Well, what about the 6th root of 2y plus 1 to the 18th? Absolute value 2y plus 1 to the 3rd. Because even powers wipe out negatives. Number 2, I don't know why these are randomly numbered here. That's it. That's it. Number 2, that negative out front, what's that do to our problem? Yeah, that's the best answer. Nothing. It's already out front, so I don't really have to worry about it. It's just going to kind of stay there. Like, don't lose it, but it doesn't do anything for my problem. Square root of 49 is 7. Square root of u to the 8th? Is it u to the 4th? Absolute value. Why is it absolute value? Because it's an even root.
Won't it stay positive anyway?
But if I plug in a negative number, oh, you know what? You're right. Absolute value of u to the 4th, or excuse me, u to the 4th will be positive anyway.
Yeah.
So I don't have to do the absolute value. Good call. Which means that I messed that up on the previous page? Any of those not right? Yeah, I think there's one more that we could simplify there. Yeah, x squared is always going to be positive. It is not wrong. You are right. You are right. That kind of thing happens in calculus. And in that exact way, there's a formula whose answer is absolute value. But sometimes what's in the absolute value is always positive, and so you don't have to put it. Some students leave it there because it's not wrong. How about square root of v to the 12th? V to the 6th. And again, you could put the absolute values on there, but it's not needed because v to the 6th is always going to be a positive number. Tricky. And yeah, that's it. We don't have to do anything else. So the computations aren't hard today, but the thinking is the challenge. 12, plus or minus. But that's already there, and it's on the outside, so just leave the plus or minus alone. Square root of 121 is 11.
Squared y, absolute value y cubed.
So I'm starting with absolute values on both of those, and then I'll think about whether they're needed or not. I think that's the safest way to go. So is absolute value needed on x squared?
Nope.
No. Is it needed on y cubed?
Yes.
Yes. Because that could end up being negative. We don't want it to be negative. So we'll put the absolute values on there. All right, 8th root. So already I'm thinking absolute value. X squared, absolute value of y. But is that the best answer?
It's just x squared absolute value of y.
Right, because x squared is always going to be positive. I don't need the absolute values. Ooh, I haven't done one quite like this, at least in a while. Not today, anyway. Square root of 25, that's easy. That's 5. What about the square root of a to the 7th? Okay, so one way to say it is a to the 3.5. That's true. That's not how we want to represent our answer. So it's not wrong. It's just not how we want to do it. Although,
7 halves.
you could think of it that way. I'm going to split it up like that.
6.
Why would I do that?
Make it easier.
Why? How does it make it easier? You're right. Yeah, a to the 6th has a square root. what do you think about splitting up b to the 5th?
4.
So let's see. So that would be a cubed and b squared, and then square root of ab on the inside.
Should a cubed be absolute value?
Yeah.
Should a cubed be absolute value?
Yeah.
Yes. Yes. Just because it says assume all expressions are defined for real numbers. If a was negative, would it mess things up?
Yes.
Well, if a was negative and b was negative, that would work. So yeah, let's put this absolute value on there.
And even if it isn't negative, it doesn't matter. Just keeps it clean up.
Good morning.
I sent you an email.
You did.
I was wondering if you sent that to my teachers because they won't let me go.
Okay. I have not. What period do you need that for? Third?
Third period, yeah.
Okay, I'll do
it's
it.
just like either or of them. As
Okay.
long as they see it, then they'll let me go.
I'll do it.
Thank you.
Fourth root, 32.
Can I get you both to do that in English?
Is 2 to the 4th 32?
You could just separate it to 16 and 2.
Yeah, it may be trying to bait you into thinking that's 2, but let's split that into 16 and 2 because 16 has a nice fourth root. I mean, it has a fourth root, it's just not very nice. I don't know what it is, but it's more than 2, less than 3. How about a to the 6th? How could I split that up so that part of it has a nice 4 and 2? Because I need something to be divisible by 4. So 4 and 2. B to the 12th is fine, and c squared I'd be stuck with anyway. So let's see. The 16 has an answer. A to the 4th has an answer. And I think everybody else is, nope, B has an answer. And I do need to think about square or positives and negatives and absolute value, but let me put the rest of this stuff sort of back in the house there. Because it's not needed every time. And it's only used if I see what you're saying. If you're doing an even root, I see you could just put absolute value on the outside of everything and be done with it. That is true. I don't know that I would like that answer, but I think it would be correct for even roots. Okay, back to what needs an absolute value here. I think the A does, right? Because if I plug in a negative A, of course it's going to make it positive, so I need to sort of preserve the positive thing. What about B?
Yeah.
Yeah, because B to the 12th is going to make it positive. B cubed might be negative, but can't have that. I guess then the question is, could you put an absolute value around both of them? Yeah, you could. All right, last one. Let's see, square root of 60. Not a nice answer. So how could I split that up to have a nice answer? 15 and 4, or 4 and 15. A to the 7th. 6 and 1. Because I'm looking for something that will divide by 2. And then in the bottom, 4 and 1. Okay, so who gets to leave here? Square root of 4, A to the 6th, B to the 4th. 2a cubed over b squared. And then still in the house is 15 and a and b. And what about the square root stuff? I mean the absolute value stuff. Let's see, if a is negative, this isn't going to work. So I don't think I need an absolute value on that, because if a is negative, it messes up the whole problem anyway. So I think I can leave that alone. Same thing with b.
Won't you have to move the b squared?
Fix that b? I do. So square root of b, square root of b. So 2a cubed, square root 15ab. What's in the bottom now?
B cubed.
B cubed. B times b, root b times root b is b, times b squared is b cubed. No square roots in the bottom. Not till you get to calculus, then you can leave it alone.
Do you have to do? You don't have to do anything for the b cubed, right?
I don't think so, because look, my main concern is negative. So just look back up here at the beginning. If b is negative, then this problem doesn't work. So I don't have to worry about b being negative. Okay, the assignment from the book, of all places. Page 411. I did give you a paper to work it on, though, right? So you're welcome. Page 411, 13 to 23 odd. 27 to 49 odd. And yes, you're welcome to take pictures. There's books under some of the desks. There's also 10 more on the bookshelf back there. And then, oops, sorry, just to make your life more fun, page 420, 19 to 37 odd. I bet those go quick, though.